Hundreds of spaceships take off from Earth's surface and head toward Mars. Fast forward 7 months, and this space fleet of ships is near the Red Planet. Soon they will all land, and a few thousand people will become citizens of Mars. Perhaps they will never return to their home planet, because there will be absolutely all conditions for a comfortable life here. It takes time and many expeditions to create a self-sustaining colony on Mars. Here is how, step by step, people might build a full-fledged city there, with factories, hospitals, apartment buildings, and even clubs and restaurants. First, we need to pick a time to launch the rocket. A launch window opens once every 780 days. That's when the distance between Earth and Mars is the shortest. In this case, the journey will take about 6 to 7 months. Let's move to the launch pad. Here, we see the spacecraft connected to a booster rocket. Ignition! The booster sends the spacecraft into the air. It then undocks and lands back on Earth. At the same time, the spacecraft's engines start and it makes its way to Earth's parking orbit. To make this ascent, the ship has used almost all its fuel and now needs refueling. To do this, we use our booster again. A huge crane places another spacecraft on the booster. There are huge fuel tanks inside the ship. The booster launches from Earth and takes the refueler into orbit. It docks with the spaceship and fills it with fuel. The journey through space may need a total of 5 such refuelings. And for the first mission to build a colony on Mars, we need 5 spaceships. So that's about 25 launches from Earth. Considering that the booster costs $230 million, the refueler $130 million, and the ship itself is $200 million, the price tag on the mission is pretty impressive. So, ignition. Fast forward in time, and the first 5 ships descend to the surface of Mars. These ships haven't brought the first humans. They carry only payloads, like fuel and water supplies, oxygen for breathing, and medical supplies. There are also first living modules, waste management systems, and a huge number of solar panels for generating electricity. Before landing, one of the ships launches a system of satellites into orbit. It'll provide communication on the Red Planet. So, the robots begin their work on Mars. First, a whole bunch of little rovers line up and unfold solar panels. Their total area reaches the size of 7 soccer fields. They're much less efficient on Mars than on Earth. Frequent sandstorms fill the working surface of the panels with sand. But at the same time, the strong winds of the Red Planet also help to wipe the sand away. Other rovers, equipped with powerful drills, begin searching for water in the Martian soil. When they find water, people will begin producing fuel. We'll combine carbon dioxide from the atmosphere with the mined water at a high temperature and under high pressure. It'll result in getting methane for rockets and oxygen for breathing. Since February 2021, Mars Perseverance rover has been testing the technology for oxygen extraction. It has a box inside. This is the Mars Oxygen IRSU experiment, also called MOXIE. This thing pulls Martian air inside and then, under high pressure, takes 1 atom of oxygen from carbon dioxide. Such a thing, about the size of a shoebox, can provide enough oxygen for 1 astronaut to breathe. But if you build the same mechanism but the size of a large factory, it'll produce oxygen for an entire colony and release the rest into the atmosphere of Mars. Another group of rovers is working to turn the surface of Mars into a landing zone to prepare for the next step in colonizing the Red Planet. By this time, the robotic population of Mars has been working on these tasks for 2 years and 2 months, and people on Earth have been waiting for a new flight window to open. This time, not 5, but 12 spaceships are coming to Mars. 10 of them are cargo ships, which bring construction materials, fuel, and other supplies, as well as a lot of scientific equipment and 3D printers. 2 other ships carry the first interplanetary astronauts. The doors of the spaceships open, and 30 heroes set foot on the surface of Mars for the first time in history. These people are scientists, engineers, and doctors. They have undergone a strict selection and long training to become the first people to conquer another planet. And these guys don't have a return ticket. They'll have to stay on Mars for 2 years. The astronauts live right in their spaceships and try to get used to the unusual conditions on Mars. The temperature here is about minus 80 degrees Fahrenheit. Also, the gravity on Mars is 2.5 times weaker than on our home planet. That means a person here can jump twice as high and lift heavier objects. But the muscles in human bodies have a hard time getting used to such a difference. So astronauts can't work full-time. The first thing they do is unload cargo ships and deploy life support systems. Some people are experimenting with turning Martian soil into material for 3D printers. Others are setting up greenhouses and cultivating soil to grow plants. The human waste recycling system the robots brought here is used to make fertilizer for plants. 2 more years and 2 months have passed. We see a launch of a spaceship, not from Earth, but from Mars. The 30 astronauts have completed their mission and are on their way home. It's easier for spaceships to take off from Mars because the gravitational force here is less powerful. At the same time, ships are launched from Earth. They'll bring nearly 100 new inhabitants and even more cargo to Mars. When this space fleet arrives at the red planet, the astronauts can taste the first food grown here. 3D printers begin building homes on Mars. They print outer shells from Martian soil and plant waste. These shells will protect the dwellings from solar radiation and strong winds. And inside the shells, people will build permanent houses. They're inflatable and are equipped with modules brought directly from the spaceships. These houses have living bays, research bays, and communication centers. The construction goes on for 2 more years until the next flight window opens again. Some astronauts leave Mars, but more and more people come here with every new mission. They no longer live in spaceships. There are comfortable underground houses and 3D printed shelters. Most of the food is already produced on Mars. A new generation of robots works together with farmers. Other robots help to build even more houses to accommodate the ever-increasing human population. 2 more years have passed. Various space agencies launch their missions to Mars. There are more people, more scientific equipment, and even tanks with fish. In 2035, Mars and Earth are at a record short distance, so people send a huge fleet of ships with astronauts and construction materials. By this time, the human colony looks like a small city with many interconnected domes. Its inhabitants have already begun building an underground network of tunnels to move between houses, laboratories, and factories. They've also built the first hospital. 2 years later, the population of Mars reaches the 1,500 mark. Almost all of these people will become permanent residents of the planet. 4 years and 2 more launch windows later, the first restaurant opens its doors. Also, the construction of a nuclear power plant begins. Once it's finished, the Martians will no longer need constant supplies from Earth. From above, the colony looks like a small town. There's a farming section where food is grown, a living section, and a factory district. And with each new mission, people bring more and more solar panels. Now their total area equals dozens of soccer fields. All this allows the astronauts to feel at home. They also don't have to wait for food supplies from Earth. 20 years of the human colony on Mars. Its population is now about 30,000 people. Workers begin to bring their families to Mars. The first schools are built here. 30 years. The population is already over 100,000 people. The colony's infrastructure allows it to be completely self-sufficient. People produce enough food, get enough fuel and oxygen. Around this time, the first plants start growing in Martian soil. There's more and more oxygen in the planet's atmosphere. The trees planted in greenhouses contributed to this. The greenhouse effect from all the human activity helps warm up the surface of Mars, if only a bit. People still have to wear spacesuits when they go outside. It will take many more years until people will be able to breathe on Mars like they do on Earth. Gradually, rivers and lakes will appear. Green plants will cover most of the land. And then the inhabitants of Mars will be able to go outside without an oxygen helmet and call the red planet, now green, their home.
The Moon. A beautiful, natural satellite with some mysterious dark splotches. We always see only one side of it, so we're used to this image. It's hard to imagine the Moon looking any other way. But it used to be different. Oh ho ho, it used to be so different. Picture this, a huge incandescent satellite in the sky that is causing constant tsunamis. I suggest we go very far into the past to see what the Moon was like many, many years ago. The Moon formed around 4.5 billion years ago. At that time, our green-blue planet was still a red-hot, insanely unstable piece of rock flying in space. We didn't have the Moon yet, and a day on our planet only lasted 6 hours, which meant only 3 hours of daylight. Volcanoes erupted all over the place, releasing poisonous gas into the air. and a bunch of meteorites regularly crashed into the planet. At the same time, 4.5 billion years ago, the so-called Big Splash occurred, or, as scientists call it, the Giant Impact Hypothesis. It claims that once an object the size of Mars crashed into Earth. Mars is about 2 times as small as our planet, so the blow wasn't too bad, but it was quite catastrophic. This powerful impact tore off part of the outer layers of that Mars-sized object and Earth. The very core of this space body merged with Earth's own dense core, and a huge number of fragments of Earth flew into outer space. So, this was the beginning of our moon, or, saying in a scientific way, the process of differentiation has begun. This is the process all planetary bodies go through at the beginning of their lives. Since the impact was very hot, its heat carried away most of the gases and liquids from the broken pieces of Earth. Only a relatively dry stone surface remained. So yeah, there is water and gases on the moon, but in very small quantities. The gravity of our planet was strong enough to make all these hot stone fragments stay in its orbit, and they gradually began to stick together. The chemicals they contained were distributed in layers. Iron, which was heavier, sank deeper inside, and lighter elements formed the surface. In a short time, 100 years or less, the ring of steam, dust, and molten rock fused together. The largest clusters with the strongest gravity attracted more and more particles, gradually forming the moon. It looked like a red-hot bubble ball. Sadly, the nucleus of this newborn moon turned out to be very small. It lacked iron and other heavy elements to form into something substantial, like a planet. The oldest rocks of the moon probably formed in the ocean of magma. And when the moon gradually cooled down, it turned out to be a white, clean, and perfectly even ball. But it was still completely different from what we have now. To begin with, immediately after its birth, the satellite was located at a distance of only 13,500 miles away from Earth. This is 15 times closer than it is now, around 238,000 miles. It's scary to imagine how huge and bright the moon looked in the sky at that moment. The view was probably both beautiful and terrifying. And, of course, such proximity caused incredibly huge waves on Earth. The planet experienced regular tsunamis. Also, at that time, the moon was spinning very fast, and it wasn't turned to Earth with only one side. But, in general, Earth and the moon had a positive impact on each other. For example, it was the moon that made our day last 24 hours. Now, Earth's axis is mostly tilted 23.5 degrees from the plane of its orbit around the Sun. Without the moon, Earth rotated rapidly, but thanks to the satellite, the planet's tilt stabilized, which led to a wide and pleasant variety of climates on Earth. To be fair, the gravity of our planet also helped the moon. Thanks to it, the moon began to rotate more and more slowly while gradually moving away from us. Over the years, its orbit has moved far away from our planet. At the same time, the moon became tidally locked to Earth. This means that its rotation period coincides with its orbital period. Or, in other words, the moon moves around itself as fast as it moves around the Earth. That's why the moon always faces our planet with only one side. When the moon moved away, tides on Earth became calmer. Now, water could flow to the most remote corners of our planet. It was then that life appeared on Earth. But back to the evolution of the moon itself. What was happening on its surface after its formation? The next stages of the moon's development were childhood and adolescence. And as is usually the case at this stage, this period was insane. No wonder. About 4 billion years ago, the solar system was going crazy. During the first 600 million years of the moon's existence, large asteroids and comets constantly collided with it. Now, they were bothering not only our Earth, but also its satellite. These impacts were the most powerful in the history of the moon. They left many large craters, which were later filled with dark rock. So, Earth wasn't enough for you, huh, space? Once, a dwarf planet crashed into the moon. It was about the size of Ceres, the largest object in the asteroid belt between Mars and Jupiter. This explosion formed the SPA basin and also forever changed the appearance of the moon. Can you see that dark spot on the far side of the moon? Right there in this very south? This spot is called the South Pole Aitken Basin. Its diameter is about 1,600 miles. And yes, it was formed by the impact I've mentioned about 4.3 billion years ago. This planet brought with it a bunch of complex and strange chemical compounds that scientists are now finding all over the far surface of the moon. These compounds began to emit a lot of heat, melted part of the lunar mantle, and, oops, accidentally woke up volcanoes. The volcanoes began to erupt furiously. A huge amount of magma was distributed over the surface of the moon. Many years later, it cooled down, leaving behind those famous dark splotches that we're so used to. They're called the lunar maria. There are much fewer craters there than on the lunar highlands. But for the last billion years, the moon has been geologically inactive, except for occasional collisions with meteorites. In general, the appearance of the moon changed forever as a result of these events, and, battered and tired, it entered adulthood. But even then, it couldn't get any peace. A bunch of meteorites decided to bother it again. Honestly, it wasn't that bad. There were many collisions, but all of them were quite small. They just left a bunch of craters and pits on the moon and maybe damaged its mantle a little. Some of the collisions deepened already existing large craters. The moon's crust was getting thinner and thinner over the years because of all the chaos going on. And now we call this upper part of the lunar crust covered with craters the lunar highlands. All those white and bright areas of the moon, the highlands. But in the end, the universe finally calmed down, for now at least, and the moon began to look the way it does today. There are still many things we don't know about Earth's natural satellite. There are moments in its history that scientists still can't accurately explain, but they're continuing to study our beautiful satellite. The data about the moon is useful to people not only for its own sake. It gives us a more complete picture of both the history of our solar system and space as a whole. So, let's hope that one day we'll be able to find out everything there is to know about the moon.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side. Sometimes when you look at the moon, you see a face smiling down at you from the moon's surface. Of course, this is an illusion, but many people see it, and that's because its surface is shaped by some sort of lunar seas and highlands. From our point of view, we see these as light and dark patches. These seas are dark parts, and large hardened lava plains formed because of volcanic eruptions that happened a long time ago. The light regions are actually the mountains and the highlands. And people all around the globe see these lunar patches as a smiling face or even some other shapes. Our brain tends to play with things of this nature, and that's a phenomenon called pareidolia. It's when you see familiar faces and shapes even though they're not actually there, similar to how you can see a face in a slice of toast or shapes while watching the clouds. And in the northern hemisphere, people see a face in those different lunar seas. The eyes are the sea of serenity and rain. The sea of clouds represents his mouth, while the seas of islands and vapors form his nose. But that's just one way to interpret this picture, and that mostly works in the northern hemisphere. If you live in the southern hemisphere, you see the moon the other way up. When they look at the moon, some see a person that looks like they're carrying a bundle of sticks. Or there's the shape of a woman. She wears her hair up and it has 2 jewels in it, and they see the left side of her face in profile. One of the craters is reminiscent of a shining diamond which, it seems, she's wearing around her neck. In some places, people may see the shape of a rabbit, whereas people from the Pacific Northwest in America even have a story about the toad they see when looking at the moon. The story says there was a wolf that fell in love with a toad, and the toad didn't quite trust the wolf since it wanted to escape and didn't know where. It simply made one huge leap and landed on the moon. Now, do other planets have beautiful rainbows like we do? The ingredients for that are raindrops and sunlight. At the moment, we don't know of a planet with liquid water on its surface, and none have enough water in their atmosphere to make it rain. But droplets of some other liquid could refract light coming from the Sun and spread it out into various colors. Titan is one of Saturn's moons, and the atmosphere there is rich in droplets of liquid methane, which probably form rain. The atmosphere on Titan is very hazy. That means that direct sunlight is not that common, but there's still a slight chance we could catch methane rainbows someday. If they really exist, they'd be similar to rainbows on Earth, but they'd be a bit broader because methane refracts light differently than water. There's a similar thing on Venus called glory. Scientists caught pictures of this optical phenomenon of sunlight falling on sulfuric acid droplets, similar to a rainbow. Jupiter is insanely big, around 11 times wider than Earth. Not only that, our planet is twice as small as its Great Red Spot, the raging storm that's been present on the planet for more than a century. Now, we owe Jupiter a lot. Its radiation is 1,000 times stronger than the lethal level for us, and the gravitational force is so powerful that it actually protects our planet from collisions. In some other planetary systems, giant planets like Jupiter can move around and migrate from the place where they were originally formed. They spiral inward and get closer to their stars. When they move around, they can cause a lot of trouble. When they get closer to their stars, they can swallow and destroy some innocent small planets or other celestial bodies that stand in their way. But if these giants remain far away from their stars, they serve as guardians of the planetary system. They protect the planets in the inner orbits and allow them to circle around a central star. Jupiter got the nickname vacuum cleaner of the solar system because it can eat up any comet or asteroid that comes close enough. It can also change their orbits and kick them out so they can't come back for a very, very long time. That way, Jupiter protects the inner planets, although sometimes it accidentally sends asteroids or comets into them, causing collisions like maybe the one that made the dinosaurs extinct 65 million years ago. Now, Saturn's rings are the most famous ones in our solar system. They are far-reaching, colorful, and highly visible. You can even see them using a backyard telescope. But some other ice and gas giants also have them too, like Uranus. It has the second most interesting set of rings in our solar system. There are 13 rings, and they're all made of very dark particles that are different sizes. They're most likely young, way younger than Uranus itself. One theory says high-speed impacts shattered one or more moons, and this may have been the matter these rings are formed of. There were way more particles of debris, but only some survived, and today are forming stable zones around Uranus, known as rings. Now, our planet lost 60% of its atmosphere when there was an asteroid impact that, as one theory says, probably created the Moon. The collision between Earth and a Mars-sized rock happened over 4 billion years ago. The debris from all that, collected in an orbit around our planet, eventually formed the Moon. Now, Venus is home to at least 37 volcanoes that were active recently, which is the first evidence that showed its interior is still geologically active. Previous research discovered that the planet's interior was warm, plus there were ring-like structures. Plumes of extremely hot material deep inside Venus rise through the mantle layer, and that's how these structures form. It's like how plumes form the volcanic areas of the Hawaiian Islands. But scientists think they were just a result of some ancient activities. They believe Venus has cooled enough and drastically slowed down geological activities in its interior by hardening the crust so much that all of the warm materials from deep inside can't get out to the surface. Speaking of volcanic eruptions, Jupiter's moon Io also has them. Our moon is pretty peaceful, but Io has hundreds of volcanoes, and it took the title of the most active moon in our solar system when it comes to volcanoes. If you could go there, you'd see plumes of sulfur that reach up to 190 miles into its atmosphere. Volcanoes there emit 1 ton of particles and gases into space near Jupiter, its parent planet, every second. This could be because Jupiter's strong magnetic field and gravitational force. Io's interior tenses up and relaxes as it orbits Jupiter, and gets closer to it and farther away from it, which generates huge amounts of energy, enough for volcanic activity. There are billions of comets in our solar system. Most of them are in the Oort cloud and the Kuiper belt. A comet generally consists of rock and ice, at least until it gets closer to the Sun. Then its exterior turns into a cloud of dust and gas, and that's why comets have their specific tails. Pluto's unique surface is a series of domes, peaks, and troughs on the planet's landscape, which may have been formed because of its many large ice volcanoes. Neither erosion nor some other geological activity has done that much, but its ice volcanoes actually push icy material up to the surface. There are also a couple of craters in this area of the hemisphere called new horizons. Asteroid impacts probably caused these. Plus, these craters aren't that geologically old. Also, the interior of Pluto probably retained heat, which enabled matter rich in water and ice to deposit onto the surface. And those specific structures I mentioned before could have formed because the water was rising up from the interior of the planet and ended up being rapidly frozen because temperatures on Pluto are extremely low, in addition to atmospheric pressures. Uranus is the second least dense planet in our solar system. The least dense one is Saturn. Now, even though Saturn is 14.5 times as massive as our planet, it's still less dense than water. This means that Saturn would float in a pool if it was more than 37,000 miles wide, so the planet would have enough space to even be in there. Whoa, that's a big pool. Now back to Uranus. Since its density level is so low, you probably experience less than 90% of its gravity, assuming you could even set foot on its cloud tops. Now Mars has pretty crazy dust storms, the biggest ones in our solar system actually. They can blanket the whole planet and last for months. One theory says these huge storms start because dust particles absorb sunlight and warm the atmosphere of the red planet. Warm pockets of air form and they start flowing toward colder areas. This generates winds. These powerful winds lift more and more dust off the ground. This again heats the planet's atmosphere, creates more wind, and kicks up even more dust. Wow, better have a broom handy, maybe even two.